The following math workout is rated MA for math. Brought to you by LACCD 3CSN in collaboration with UCLA. So it's late at night, and instead of doing your math homework, you're watching your favorite TV show. You're focusing in on your favorite scene from the show. In fact, you want to savor that moment forever. You even find a screenshot of the scene. The one here, for example, is 4 inches wide by 3 inches high. We say it is a 4 inch by 3 inch screenshot or picture. What if we wanted to blow up our screenshot so that it is poster sized, perhaps to hang in a room? How do we make the picture larger without distorting it? Doubling the height only while keeping the width the same doesn't work. Nor does doubling the width only while keeping the height the same. In each case, we get a distorted image. Notice that we also get distortion if we were to go another direction and instead, say we add a number like 3 to both dimensions. Adding 3 inches will also produce a distorted image. However, multiplying both dimensions, width and height, by the same number will create an image that is not distorted, one that we could use for our poster. The reason behind this is the concept of a ratio. A ratio is a comparison between two different quantities A and B, written A to B using column notation for the English word to, or A over B using fractional notation where B, the denominator, is different than 0. Be aware. Even though we use fractional notation for a ratio, the two are not exactly the same. The two are not exactly the same because a fraction represents a part of a whole, whereas a ratio simply compares the two different quantities in a part-to-part relationship. Let's take a look at an example of this fact. We have a wheel with 3 yellow sectors and 1 red sector. We say that the fraction of red sectors in the wheel is 1 over 4. This is a part-to-whole relationship. We're comparing a part of the wheel, the red sectors, to the whole wheel. On the other hand, we say that the ratio of red sectors to yellow sectors in the wheel is 1 over 3, or 1 to 3. This ratio is a part-to-part relationship. It compares two different parts of the wheel, namely the red and yellow sectors. Going back to our poster, we knew that we started with a 4 by 3 inch picture. So perhaps doubling both width and height will create a non-distorted image as we expected. As you could see, that's exactly the case here, where we get an 8 inch by 6 inch picture, a result of doubling or multiplying both dimensions by 2. In general, multiplying both width and height by the same value will create a non-distorted image, as shown again here, where we've multiplied both by 1.5 to obtain a 6 inch by 4.5 inch picture. Multiplying both dimensions by 2, 1.5, 5, 10, or any other number preserves the part-to-part relationship between width and height, and thus avoids distortion. In math, we say that the ratio of 4 inch by 3 inch is preserved. You might have encountered a similar situation when watching TV, where the picture might be stretched or transformed in some other way. Let's explore further in the following video.